In this video, I'd like to talk about the features of sinusoidal functions. And a sinusoidal function is either the sine function or the cosine function. Since remember that sine and cosine are really the same function, but they are shifted versions of each other. Since if we look at the relationship between the two, we know that when we take the sine function and we add pi over 2 radians to its angle x in this case, that this is simply equal to the cosine function. In fact, if we had a graph of the sine function, by adding pi over 2 radians to this independent variable, this angle x, we shift the entire graph to the left pi over 2 radians, and by doing so, we get the cosine functions. So both of these are called sinusoidal functions since in some sense they are the same function, just shifted versions of each other. And the main features of these functions that we want to consider are the function's amplitude, the midline of the function, and the period of the function. So let me make a little bit of room and we can paste in a picture that defines all three of these features. And with this picture, we can see all three of the features defined here, where the midline is the line, the horizontal line, that exactly splits the function in half. It is the exact distance from the maximum value of the function to the minimum value of the function. It is right in the middle of those 2 points, where the amplitude, that is the distance from the midline to either the maximum point or from the midline to the minimum point. And the period, these functions are called periodic functions because they repeat. The period just shows one interval before any repetition occurs. And notice with this particular graph here that we start at the midpoint, it goes up to a maximum, then comes back down to the midpoint, goes down to a minimum, and then comes back up again. And then after that, it starts repeating. It starts going up to the maximum point again, it'll come back down, go to the minimum, and then back again, and it'll repeat infinitely many times. And we say the period is just that distance from when it starts going up to when it finishes by going back up to that same starting point. So this distance right here we call the period, and this period, that interval where the wave is unique, it doesn't repeat yet, that will repeat infinitely many times in these sinusoidal functions. So if we look at a specific example here, we can find all three of these different values. And remember that the amplitude deals with the maximum points and the minimum points. And the midline will be right in the middle of those maximum and minimum points. And since the maximum point has a y value of 7 and the minimum point has a y value of 3, we can find the midline by taking their average. We can add 7 plus 3 and then divide by 2. By averaging the points, we get 10 over 2, which is 5. We can find the point directly in the middle of those two y values. And that would be a y value 5, and that should make sense. Since notice that this y value 5, let me draw in the actual midline here. This y value 5 would be a distance of 2 to the maximum value of 7 and a distance of 2 to this minimum value of 3. And once you find the midline, you can find the amplitude. Since the amplitude is just the distance from that midline to either the maximum or the minimum, and in both cases we know it's 2 units, either up to the maximum or down to the minimum. Now the period, we look at some starting value. We can really pick any value, but usually we pick a value on the midline. And we notice it goes up, comes back down, passes through the midline, and then goes all the way down to its minimum, and then comes back up again, and then repeats that process. So every time that process is completed, we pass through one period. So the period starts here and ends here, and we just got to figure out that total horizontal distance it went, which notice is at 0 when it starts and at 4 when it finishes. So the period for this sinusoidal function would be 4.